Imagine holding your newborn for the first time, while scientists hold the key to their genetic future. What if a drop of blood at birth could spell out not just your baby's health risks, but their entire medical destiny? This isn't science fiction. It's happening right now, and it's set to disrupt the global healthcare and business landscape in ways most people can't even imagine. Across the world, a genomic gold rush is underway. The surge isn't just about decoding DNA, it's an epic transformation, one that could redefine what it means to be human, what it costs to stay healthy, and who gets to benefit. As genomics becomes big business, the stakes have never been higher, from Wall Street to the world's hospital wards. So how did we get here? To understand the rising tide of genomic technology, let's travel back in time. For centuries, Alderley Park in the UK was just a family estate, until it evolved into a powerhouse of pharmaceutical innovation. Today, it stands at the crossroads of old and new, the brick walls of legacy research blending with the glass towers of tomorrow's biotech. It's here that Revity, a global genomics and diagnostics company, is doubling down. Their expansion into Alderley Park is more than a real estate move. It's a bet on the future of healthcare, one where genomic data, AI, and next-generation screening can predict, prevent, and personalize medicine at scale. The numbers are staggering. The global genomics market is on track to explode from today's $28 billion to nearly $160 billion by 2033, growing more than 12% every year. Personalized genomics, once a luxury for the few, could top $52 billion by 2034. These aren't just numbers on a spreadsheet. They signal a seismic shift in how we diagnose, treat, and even prevent disease. At the heart of this revolution is the Generation Study, a partnership between Revity and Genomics England. Their goal? To make large-scale newborn genomic sequencing the new gold standard. Using advanced chromatic technology for nucleic acid isolation, Revity aims to scan for rare inherited diseases at birth, long before symptoms emerge. AI and machine learning now turbocharge this process, analyzing mountains of genetic data that would have swamped human experts just a decade ago. As one industry analyst put it, AI/ML-based computational tools are essential for handling and interpreting valuable information in genomics research and development. But why is this transformation happening so fast, and why now? For one, the cost of sequencing a whole human genome has crashed from billions of dollars to just a few hundred. Meanwhile, nations like the US have launched massive programs to collect genomic data at scale. The NIH's All of Us research program aims to sequence 1 million Americans, promising a databank of DNA that could power research for decades. Luciana Constantino, a policy expert, puts it bluntly. Bringing genomics into public policy requires greater awareness, professional training, and investment to ensure ethical implementation. In other words, the science is racing ahead, but society may not be ready for the consequences. It's easy to get swept up in the promise. Genetic screening is becoming not just more accurate, but more affordable. Rare diseases, once a diagnostic nightmare, can now be flagged within days of birth, giving families hope and doctors a head start. Blake, an executive at Revity, claims, genetic testing is becoming more affordable and should be considered as a first diagnostic option for many conditions. If that comes true, routine DNA screening could soon become as common as having your temperature taken. But behind the optimism, challenges loom. Let's step into the main conflict at the heart of the genomic revolution. The first problem? Data privacy. Your DNA isn't just data. It's the most personal information you'll ever possess. As more babies are sequenced, who owns that data? Hospitals, private companies, or the government? The stakes are enormous. If hacked or misused, genomic data could be weaponized for discrimination, insurance denial, or worse. The potential for abuse haunts advocates and critics alike. Ethics is another fault line. As Robert Steiner, a genetics specialist, says, genetic testing can significantly affect health and change lives, providing crucial insights for personalized care. But it can also open a Pandora's box of questions. Should parents be told about every risk? What about findings with no cure? And who decides what a normal genome looks like? There's also the issue of access. As cutting-edge tests roll out, will only wealthy families benefit, deepening healthcare divides? Or can governments ensure that personalized medicine reaches underserved populations? Meanwhile, AI and machine learning, the very tools accelerating this field, add another layer of complexity. Algorithms trained on incomplete or biased data could reinforce existing inequalities. And if an AI flags a genetic risk, but no doctor can explain the result, who's responsible? Fast forward a decade. Experts like Eric Green, director of the National Human Genome Research Institute, predict comprehensive genomics-based healthcare is expected to be the norm within 50 years, transforming medical practice. But how do we get there without turning society into a genetic dystopia? Technology also brings new fears. Gene editing tools like CRISPR promise to cure diseases or create designer babies. Meanwhile, hackers and cybercriminals see a new frontier for theft and blackmail: genomic ransomware. Every opportunity seems to come with an equally daunting risk. How can regulators, companies, and citizens keep up with the pace of change? And let's not forget the global picture. While places like Alderley Park become hives for genomic innovation, billions of people in developing regions risk being left behind. As preventative genomics and gene therapies go mainstream, will the benefits be shared or hoarded by the rich and powerful? As this high-stakes game intensifies, one question looms. In our rush to unlock the secrets of DNA, are we creating new problems faster than we solve old ones? The world stands at the threshold of a genomic era, with incredible promise and peril. What will tip the scales, and who will decide what comes next? As we step into the heart of this transformative era, the intrigue surrounding genomics only grows deeper. Though Revity's expansion and the boom in newborn screening have opened up incredible opportunities, they have also laid bare a new set of consequences and dilemmas that extend far beyond the lab. The future of genomics isn't a simple story of progress. It's a rapidly evolving tale of risk, hope, and uncharted ethical territory. So what might our world look like when the genome becomes the foundation of healthcare, and who stands to gain or lose? Let's imagine a world in 2035. Newborn genetic screening is standard in hospitals from Boston to Bangalore. A few drops of blood, analyzed in minutes by AI-driven platforms, reveal hidden risk factors for hundreds of conditions, from rare metabolic disorders to predispositions for diabetes, cancer, or heart disease. Families can plan ahead, get early interventions, and perhaps even take preventive medication tailored to their own DNA. Personalized medicine, once the dream of science fiction, becomes just medicine. But this future is a double-edged sword. The same data that could save a child's life or prevent disease could also be used to deny someone health insurance, employment, or even basic privacy. Algorithms are neutral. People, organizations, and governments are not. The very genetic information that empowers an individual could be weaponized against them, with or without their knowledge. We've already seen glimpses of this. In 2023, a major health insurer in the U.S. was quietly caught refusing coverage based on genetic predispositions flagged in customers' records. Laws like the Genetic Information Non-Discrimination Act, GINA, exist, but the lines move as technology leaps forward. What happens when your entire health profile can be decoded at birth? Who gets to decide how that information is used? Luciana Constantino, a renowned genomics policy advisor, puts it plainly. Bringing genomics into public policy requires greater awareness, professional training, and investment to ensure ethical implementation. In other words, the future will demand not just new tools, but new rules, and people ready to enforce them. On the other side of the coin, AI is propelling genomics at a staggering pace. Machine learning sifts through data from millions of genomes, spotting patterns invisible to human eyes. According to one industry expert, AI, ML-based computational tools are essential for handling and interpreting valuable information in genomics research and development. This isn't just speeding up research, it's redefining what's possible. Breakthroughs that once took decades now unfold in mere months. Consider CRISPR. In the next decade, gene editing therapies could shift from labs to clinics, offering the promise of cures for previously untreatable diseases. Imagine a child born with a genetic form of blindness receiving a one-time gene editing shot and seeing their parents for the first time. It's the kind of miracle medicine that stirs hope and fierce debate. But here's the twist. Access to these miracles is not guaranteed. The cost of advanced genomic testing and therapy can be astronomical, often putting them out of reach for less affluent families and communities. Even as Revity and its peers tout the promise of equitable access, the practical reality today is deeply uneven. This raises the risk of a new kind of inequality, a genetic divide, where the benefits of the genomic age accrue to the wealthy and well-connected, while large swaths of the population remain on the outside looking in. The question is not just who will benefit, but who will be left behind. As Eric Green, director of the National Human Genome Research Institute, declared, Comprehensive genomics-based healthcare is expected to be the norm within 50 years. But who defines comprehensive? And how can we ensure the future isn't just distributed to the privileged few? Now let's talk about cyber risks. As more genetic data is digitized and shared, it becomes a goldmine for hackers. One high-profile breach could compromise the privacy of millions, exposing not just medical risks but family secrets, and even identities. Imagine the impact if your DNA profile became public information, searchable by employers, insurers, or even scam artists. The threat isn't hypothetical. Cyber attacks on health data systems are rising every year, and genomics is an especially attractive target. Cybersecurity, once the concern of IT departments, is now a frontline issue in the fight for genetic justice. Amid these complex scenarios, a few things are clear. The genomic revolution is coming, and stalling it is neither likely nor wise. The potential to save lives, especially through early intervention in newborns, is simply too great to ignore. According to Dr. Robert Steiner, genetics specialist, genetic testing can significantly affect health and change lives, providing crucial insights for personalized care. For countless families, this is already becoming reality. But how does all this affect you, the viewer watching this video, perhaps wondering what role genomics will play in your own life or the lives of your children and grandchildren? First, awareness is your best defense and your greatest opportunity. Whether you're a patient, a parent, or simply a citizen, it pays to understand both the promises and pitfalls of genomic data. Ask questions. Who owns your genetic data? How will it be stored and protected? Can you opt out or opt in for greater benefits? Demand transparency from healthcare providers, insurers, and governments. Second, the choices you make about genetic testing matter. As testing becomes more affordable and accessible, signals industry leaders like Blake are quick to highlight. Consider how it may help you, but read the fine print. What protections exist in your jurisdiction? Are there safeguards against discrimination where you live? In some countries, new laws are being drafted specifically for these questions. Stay informed, and don't be afraid to advocate for your rights. Third, remember that the benefits of the genomics revolution are amplified by community and policy. If you're passionate about fair healthcare, consider supporting organizations that fight for data privacy, equitable access, and strong ethical standards. Push for public investment in genomics literacy and professional training. As Luciana Constantino reminds us, ethical application won't happen by accident. It demands vigilance and collective action. And finally, don't forget the human element. As advanced as AI and machine learning become, the most important decisions about our genetic future will be made by people, doctors, policymakers, patients, and you. Genomics isn't just a story about code in a cell. It's a story about values, justice, and the kind of society we want to build. So, can we harness the power of genomics without falling into a dystopia of surveillance, discrimination, and genetic inequality? The answer isn't black and white, but there is hope. The tools exist: laws, technologies, public awareness, and a growing movement for responsible innovation. The biggest barrier is not science, but willpower, the willingness to make tough choices, confront uncomfortable realities, and keep pushing for a future where genomic knowledge lifts everyone. As Blake from Revity put it, genetic testing is becoming more affordable and should be considered as a first diagnostic option for many conditions. This is more than an industry talking point. It's an invitation to a new healthcare paradigm that can be proactive, predictive, and preventive. But with every step forward, we must remember what's at stake: our data, our health, even our identities, all encoded in those twisting strands of DNA. The fight for who controls our genetic future is just getting started. And here's a secret fact. The largest single genetic data initiative in history is already underway. The NIH's All of Us research program is collecting the entire DNA sequences of 1 million Americans, aiming to make breakthroughs that could affect every corner of medicine. But participation is voluntary, and the rules about data use and sharing are being written even as you watch this video. The future is not set, it's being shaped right now. So, if you care about your health, your privacy, and the world you'll leave to the next generation, now is the time to get informed. Start by talking with your doctor about the pros and cons of genetic testing. Join public discussions. Support policies and leaders who value both innovation and ethics. Because the genome is not destiny, but what we do with it, together, could define the destiny of healthcare for generations to come. Thanks for watching. If you found this exploration eye-opening, hit like, subscribe, and share your thoughts in the comments. What excites or scares you most about the genomics revolution?